Hi, Mark Gillan here. Thank you very much for coming along to the video tutorial for using probability predictions. There are some more video tutorials available to you, lots of them, including one that explains probabilities and the rules of mathematics for probabilities. This one is going to help you to understand the using of the probability predictions. And here we go. Let's get into it. So first of all, just a wee reminder of probability for you. So we're looking at the probabilities that can be described in words. So we have the no chance, we've got some chance, we've got evens, and then we're moving up there towards the yes there is. Let's have a wee look. There's also a scale that we can use as well, where we have the one that's certain. It's definitely going to happen. So the words can go in line with that. So we have the scale of 1 certain, the 1 to 2 chance, which is half the possibility is 1 out of 2, and also the 0 for impossible. We also have probabilities that can be calculated to fractions, which I just mentioned one there. The chance of it happening evens. The chance of 1 or 2. So you flip a coin, one coin, if all is correct there, then what will happen? You've got a choice of heads or tails. There's a chance of 1 out of 2 possibilities there. So there's a possibility of heads, there's also evens possibility of tails. So that's 1, 2, which is half. It can also be calculated then from the fractions into decimal and also into percentage. So there's a 50-50 possibility of it being heads or tails. And it's obviously the same for both. So if you say that it's a 50% chance of heads, it's a 50% chance of tails. There's also the sum of possibilities calculation, which we've looked at previously. And what we did was we looked at the possibilities with more than one event happening at the one time as well. So we looked at the possibilities throughout what could be happening there. Who knows, you could even try it with a lottery. There's also, like I said, there's the combined events, but we could use a table for calculating out the fraction. So what we do is we use a nice table and we mark up. There's another tutorial for that if you need to look that up and you're not too sure of it. So the probability calculation that we're speaking of there. If the probability is chance of happening of 4 and 7, obviously the other way around is going to be 3 and 7 for anything else to happen. So if there's a chance of something happening 4 and 7, well, we can also write that as 4/7, 4 over 7, which is 4 divided by 7. And if we do the 4 divided by 7, it makes it into a decimal for us, and that would be 0.5714. So if we have a chance of 0.5714 of something happening, such as the probability of a production line having, say, faulty units, so maybe hi-fi units or something, so we get a possibility of that. Now that's quite high, that's actually quite high for a production line, you'd be worried about that. But if we were working on that, we can use this value to predict the outcome for multiple values. So we can do what ifs. So what if the production line were to increase? So let's have a wee look at some examples here. So if the production line made 500 hi-fi units, and from the 0.5714, if we multiply that into the 500, then we get 285.7. So there's a probability that 285.7 units, now we could round that off as well, will be faulty. And obviously the rest wouldn't be, they would be fine. So that gives us an indication as to the what if. So what if there was 800 units that were going to be made by the production line? So if we upped it, well, the probability, as long as everything stays the same in all respects about any other influences on it, then the probability then, we round it off, 800 multiplied by your 0.5714 would give us 457 units, round off from the exact calculation. So it's a chance of 4 in every 7 units, and we'd be working on that basis with what ifs based upon that probability calculation and everything else staying the same. So let's have a wee look at another one. You give this one a wee try. So if there's a probability of every second person out of each 7 customers entering a museum as being senior citizen, what if 1,430 people visited the museum? How many are likely to be a senior citizen based upon that probability? Right, you can pause this video if you want and write it down and have a wee try, or do it in your head or whatever on the calculator. So try and work that out. So pause the video, have a think about it, then come back and see if you're right. Okay. Right, hopefully you paused the video or you just watched it and you've got your answer there and you've figured it out. So as I said, for every second person out of each 7 customers, so you've got to think about the probability there. Right, I'm going to give you another one and then we'll think about the answers. I'm going to give you a wee hint first of all there as well. So think about that every second person out of each 7. So you've got a ratio there. You can work that ratio into a fraction, into a decimal. So here's another one for you. If 2,950 people visit the museum the following week, how many are likely not to be a senior citizen? And that just goes to show that for every question, you've really got to read questions and think about what they're looking for in the answer. So again, you can pause this video whenever you want. Okay. If you paused it, we're back anyway. So here we go for the answers. So I would want you to have thought about it anyway based upon that, because if you're not sure of things, you can always rewind. And you can do that for any of my video tutorials. I always try and throw some wee questions in for you to have a wee bash, and then I explain them. So the answers, let's have a wee look at them. So the first question that we had is based upon the probability, and said there that every second person out of each 7 customers would possibly be senior citizens. That's the probability. So you'd work out the probability, I did say, as a fraction, so it's a chance of every 2 out of every 7. So it's 2 over 7. If you divide that out, 2 divided by 7, you get the decimal of 0.2857. So the next question, the question was, if 1,430 people visit the museum in a week, how many are likely to be senior citizen? There's a wee spelling mistake there as well, isn't there? Just noticed that. Okay, so it's how many would likely be a senior citizen, not like. Autocorrects, oh, is the bane of our lives nowadays, isn't it? So 1,430 multiplied by the ratio decimal. So 0.2857 gives us 409 senior citizens. Now, we round that off because we don't have parts of people, but we could keep it as an exact if you wanted to. It's fine. And the second question was, if 2,950 people visit the museum the following week, how many would likely not to be a senior citizen? There, I got it right there, didn't I? Likely. So 843 senior citizens. So then we deduct that away from the 2,950 that would be visiting the museum. That would then let us know how many, so it's the opposite, obviously. So it'd be 2,107 that are likely not to be senior citizen. So now what we've done is, just to summarise, we had a wee look at the probability again, we had a wee brief going over of that. Then we looked at the fact that we can address the probability as a ratio, but what we can also do is we can look at the probability as a fraction, and then look at the fraction there into decimal. And with that decimal, we can then multiply that out on an amount to find out the probability of that amount. So we've looked at the use of that, and we've had a couple of questions there. So we've got the use of the probability calculation now. So we always like to put things into practice, and every day we do. Quite often we put things into practice. So I hope you've enjoyed. Thank you very much for coming along. There's plenty of other video tutorials to help you. I hope they do, and I hope you do enjoy them. Thanks very much, and all the best. Bye just now.